Hello everyone! So in this video, I'll be talking about the Earth's interior, inside the Earth. So before we talk about the Earth's interior, let's just go to a simple question I used to have. Can you go to the Earth? Well, the answer is no. But let's just think of what if you could go to the Earth. And if you could go to the Earth, it's most likely you're going to end up in an ocean. For I live in the continental USA, and if I go anywhere in the continental USA, I'm going to just end up in the Indian Ocean, which is between Africa and Australia. And the place where I'm going to end up if I just dig I just dig straight down the earth is called the antipodes. And the antipodes is sometimes also referred to as Australia because Australia is exactly opposite of Britain. So if you dig from Britain and to go to the antipodes of Britain, you're going to get to Australia. And that's why we sometimes call Australia antipodes. So now let's go to the Earth's interior. And so this is a good image because it shows all the layers of the Earth. So this brown layer over here, it's really thin, is the crust, and it's 70 kilometers deep, and that's really deep. That's 43 miles deep. And just to give you some perspective, the Grand Canyon is just 1 mile deep. Just try to think of 43 Grand Canyons stacked up on top of each other, and you'll get how deep the crust is. Very, very deep. And that's just this thin layer over here. And the crust is where we all stand. And the crust is made of two parts, the lithosphere and the hydrosphere. The hydrosphere is all the water, and the lithosphere is all the rock. So the plates on the earth are like this just think of it like you have a box and you put some jelly sauce inside it, and then you just put a lot of paper, rectangle sheets papers on top of it, and you can see that those rectangle paper or maybe some rectangle cardboard or something, they will float on the all around that jelly. And instead of jelly we have got lava, molten lava, and instead of cardboard we've got the plates, which are the land cut apart. So if you took a world map and just cut it up in pieces and then you just placed it around the globe, you get the idea. So the mantle is the next part, and the mantle is really, really hot. And the mantle is very deep too. It can reach to 1,795 miles. Really deep. It's almost, you can't even imagine 1,795 Grand Canyons stacked up. And the mantle is very important for the plates, because the mantle is important for the movement of the plates. So that's the fundamentals of plate tectonics. So what is going on in the mantle is, so here we have an image, and as you can see, this is the mantle, and this top layer of the mantle is the asthenosphere. So we call this the lithosphere, and as I said, that's the rock layer part. And so we call this a continental crust, and the oceans would be oceanic crust. And the continental crust, as you can see, is going down to the earth. And what's going on over here is that the mantle, the hot air in the hot parts of the mantle is rising, and I'm actually making another article. I'll make future videos and maybe just articles about why hot air is less dense. But the hot air is less dense, so it rises, and that's why hot air balloons rise, because the hot air is less dense. And the hot part of the mantle, it will just rise, and it'll come up here. But when it gets up here, it gets colder, because this part is colder than this part over here. The deeper you get to the earth, then the more hotter it gets. So this part is cold, so then it turns to cold parts, and the cold parts will just sink because cold air is more dense. So when it sinks, this movement of the hot air coming up and pushing the plates, and then going down back into the turning into cold part, goes back here, back to the bottom, turns into a hot part, and then this cycle is called convection. So that's how the mantle works. And the next part is the outer core. And the outer core is, well, it's 1,400 miles, also very deep. And the outer core is completely liquid. So it's not as like a murky, thick liquid like the mantle. It's completely liquid. And the last part is the inner core, which is, as this is exactly the radius of it, since it's like a ball inside our Earth, and it's very hot, and it's 2,165 miles. So that's the radius of our core. And so if you were to try to go dig to the Earth, so if you tried to dig to the Earth, when you get to the core, then it will be really hot. And actually, the biggest hole in the deepest hole that's ever been made was in Russia, and we call it the Kola Super Deep Borehole. And it was only 12.2 kilometers, just 7.5 miles. And that is a lot, but it was only that compared to the crust, which is 70 kilometers, 43 miles. As you can see, it has like only done less than a fifth of the it's like done a fifth of the crust. It has only dug a fifth down of the crust. And so that's just a small amount compared to digging through the Earth. And if you could, like you just kept on digging, and why the Kola Super Deep Borehole stopped is because your metal would just melt. If the metal gets into your tools, will soon melt if they get to such deep distances. And even though they were just like 12.2 kilometers, their metal was melting. So if even the metal, you can imagine how how hot it would be. So that's it for this video, and thank you for watching. Bye!